Hello everyone, this is the video lecture of section Appendix H1, polar coordinates, curves in polar coordinates. Most of the materials you already learned in pre-calculus 2 or math analysis in high school. Okay, so the first 70-80% of the material will be a very quick review, and the last 20-30% of the materials is the new material for calculus. So, first of all, Appendix H1. So polar coordinates is used in order to locate position. Let's say this is xy coordinate, then this is x, and this is y, right? Now this one, polar coordinates, we use the distance from the origin to the point. The angle is angle measure from the positive x-axis counterclockwise. Okay? Now, we find that allowing negative value of r is quite convenient. So, what does it mean by negative value for r? That is just the other side. Negative of r theta. Okay? Same distance, but the other side. So negative value means the positive value, absolute value of that value as a distance instead of theta, opposite side. That means this is, theta plus pi more, right? So as a point, this is same as r theta plus pi. Okay? So that way we can expand polar coordinate to include negative value for r. So negative r value means that the given angle value theta is not our direction. The opposite side is our direction, with the absolute value of this r value as distance. So for example, obviously this is same as r theta plus 2n pi. 2n pi means 2 pi is one term, right? N terms. Later, you get in the same position, right? Likewise, theta plus pi plus 2n pi. Or you can write it this way as r theta plus 2n plus 1 pi. Half multiple pi. So, let's do example 1. Plot the points whose polar coordinates are given by a 2 pi over 6, b minus 2 pi over 6, c 2 minus pi over 6, okay? And d 2 5 pi over 2, 2 5 pi over 2, and then e minus 2 3 pi over 4. Okay, I think I need a new. A. So pi over 6 over here is 30 degrees. Distance 2. That would be the location. Minus. So this is 2 pi over 6. Minus 2 pi over 6. Distance 2 away, but opposite side of pi over 6. So So it'll be 2 minus pi over, no, minus 2 pi over 6. As a point, this is same as 2, 7 pi over 6, the other side. Okay? 2 minus pi over 6. Same distance 2 minus pi means going down clockwise. 2, 5 pi over 2. 2, 5 pi over 2 is 2 pi plus pi over 2. So you're going one turn and then pi over 2 more. So over here. Distance is 2, 5 pi over 2. So which is same as 2 pi over 2, right? Adding 2 pi or integral multiple of 2 pi will get you where you started. Minus 2, 3 pi over 4. Now 3 pi over 4 is that direction. Minus 2 means the other side. Minus 2, 3 pi over 4 is same as 2 adding pi, 7 pi over 4. Or you can write it this is subtract 2 pi from here, minus pi over 4, minus pi, right? Same thing. Okay, that is E. Now, obviously once you introduce new coordinate system, you should know how to convert between old coordinate system, xy system, and new coordinate system, r, theta, polar coordinates. So, from this, you see that this is exactly the way we measure theta in trigonometry, right? That is, sine theta was defined as y over r. This is how we defined trig function, sine, cosine. When you measure theta from the positive x-axis counterclockwise, r is the distance, then you get y equals r. So write it in the order. So r equals, no, y equals, sorry about this. Y equals r sine theta. From here, x equals r cosine theta. So that would be conversion from r theta to xy. Now, even though we started with positive r value only, even if r is negative, that will be corresponding to cosine theta plus pi, sine theta plus pi. Okay? So it'll work even if r is negative. Okay? Still xy coordinate will follow this. Because cosine theta plus pi will be same as negative cosine theta. Sine theta plus pi is also minus sine theta. You can prove this using angle addition formula of cosine and sine. You can do that. It's because of that. If you have pi plus pi, it will be minus r cosine theta minus r sine theta. So minus r theta will be same as r theta plus pi. Same thing. Okay? So it works even if r is negative value. Alright? Now, we can get, what about xy coordinate to r theta? We can choose r to the square root of x squared plus y squared. As we just mentioned that r can be a negative number. Now, if you have a choice, there is no reason to choose negative value for r. That's just a self-torture, right? Just complicated. So we choose positive value of r. Then our theta is in really the direction of the position. Well, we know that tangent theta has to be x over y from tangent, definition of tangent, right? This is good enough. Now, theta is not necessarily this. Sometimes yes, not necessarily. You have to be careful. Now, if your xy is in the first quadrant or fourth quadrant, where tangent inverse functions range, then yes, it'll be equal to. So if tangent inverse give you only the angle from minus pi over to pi over 2. So if xy is in the second or third quadrant, you can't have theta value out of this. Alright, that's why. But at least this value will give us reference angle or negative value reference angle. Okay, let's do some example. Example 2. Convert the polar coordinate or 2 pi over 3 to Cartesian coordinate. Coordinate means coordinates. Cartesian means rectangular coordinate system, named after Descartes. Okay, so r equals 4, theta equals 2 pi over 3. R theta to xy is easy. X equals r cosine theta, 4 cosine 2 pi over 3. Reference angle is pi over 3. In the second quadrant, where cosine is negative. Cosine pi over 3, negative cosine pi over 3, which is negative 1/2. So negative 2. And y, r sine theta, 4 sine. In the second quadrant, sine is positive, so this positive sine pi over 3. Square root of 3 over 2 times 4, so 2 square root of 3. Okay? So, your xy coordinate will be minus 2 and positive 2 square root of 3. Okay? And what about conversion from rectangular to polar? Example 3. Convert the Cartesian coordinate given Cartesian coordinate to polar ones. Okay, A equals minus 1, 1. B equals negative 4, negative 3. Okay. Okay, x equals negative 1, y equals 1. We can choose r to be square root of x squared plus y squared. So 1 plus 1, 2. So square root of 2. What about theta? Tangent theta equals y over x, 1 over negative 1, negative. Yeah, tangent inverse of negative 1 will be minus pi over 4. But negative 1 is in the second quadrant, right? Not here. It's minus pi over 4. You know, because tangent theta plus pi is always same as tangent theta, which means tangent is a periodic function with period, the fundamental period pi. So if it is not minus pi over 4, then pi more. Adding pi, 3 pi over 4. Okay? So our theta has to be not minus pi over 4. If that value gives you a wrong quadrant, then you just have to add pi. That will be our theta. So polar coordinate r theta will be of 2, pi over 4. Of course, if you choose minus square root of 2, then you can add pi or subtract pi to go the other side. Okay? But we don't want to do that. So if we have a choice, obviously we prefer positive value of r. Okay? What about b? b, again, we choose r to be x squared plus y squared. 16 plus 9, 25, so 5. Again, tangent theta equals y over r, y over x. It's negative 3, negative 4, 3 over 4. Tangent inverse of 3 over 4 is about 0.6435 radian in radian. Now, positive inverse, tangent inverse of positive value will give you the first quadrant angle. So, you know, around here. But that's not where our point is. Our point is should be the other side, right? So again, this is in the wrong quadrant. Therefore, our theta should be pi more, which is about 3.785. Therefore, our r theta should be 5 and 3.785 radians over here. Okay? So, in this conversion, our theta has to be either, so theta sine y over x give you tangent theta value. So theta will be either tangent inverse of y over x or tangent inverse y over x plus pi. If it is in the first and fourth quadrant, which means minus pi over 2, pi over 2. This one is either second and third quadrant, pi over 2, 2, 3 pi over 2. Those, all right? Okay, let me check recording before we continue. Next topic is graph of a polar equation. So we want to learn how to draw the graph of a polar equation. Graph of a polar equation, in this case, only this one. R equals a function of theta. Okay? Except for a special case when r equals 3. This means theta can be anything as long as theta r equals 3. At distance 3 from the origin, that would be a circle with radius 3, right? What about theta equals pi over 3? Now, 0, pi over 3, 1 pi over 3, 2 pi over 3. These are, these points. 3 pi over 3, 4 pi over 3, 5 pi over 3. They're all on this line. Well, in the other side, this is negative 1 pi over 3, right? And negative 3 pi over 3. So the opposite side will be also satisfying this as long as r value is negative value. So this equation says that as long as theta equals pi over 3, no matter what value you have for r, you are on the graph. So that would be the entire line through the origin with the angle pi over 3. Okay, those are special cases. Example 4. Graph the equation r equals 2 cosine theta. Okay. One way to draw this one is we think about these special intervals, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi, and keep going, right? And then 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, and then 5 pi over 3, 7 pi over 4, 11 pi over 6, and 2 pi, right? But the r value, corresponding r value is, this is the way you draw the graph y equals f of x if you don't have any knowledge about the shape of f. What would you do? You would just collect some of the x, y, corresponding x, y values, like -3, -2, 1, -1, 0, 1, 2, 3. Calculate the corresponding y values, and you plot those points in the xy plane, and then guess from there, right? Just like that. We're going to find a bunch of points satisfying this equation. And from there, we want to guess, educated guess of the shape of the graph. When r equals 0, cosine 0 equals 1, so 2. Cosine pi over 6, square root of 3 over 2 times 2, so square root of 3. Square root of 2 over 2 times 2, square root of 2. 1/2 times 2, 1. Cosine pi over 2 is 0. Minus 1/2 times 2 minus 1. Minus square root of 2 over 2 times 2. Minus square root of 2. Minus square root of 3. And minus 2. And then later, this is minus square root of 3 over 2. So minus square root of 3. Minus square root of 2. Minus 1. 0. And then cosine 5 over 3 is 1/2, so 1 back to 2, right? So if you draw the graph, when theta equals 0, you're at 2, right? And at theta equals pi over 2, this is length 2, but this is about 1.7 something, so it'll be a little bit shorter around here. At pi over 4, that direction, 1.4 something. Length 1, length 2, around here, right? And then here you have length 1, same length. And then over here, right? We have something like this, a bit higher, lower. At pi over 2, your r value is 0. See? When theta equals 0, the distance, r value from distance from the origin is 2. When theta equals pi over 6, that direction, your r, distance from the origin is about 1.7 something. So you measure from that direction, in that direction, about 1.78 something. And pi over 4, your r, distance from the origin must be square root of 2, 1.4 something. So you measure 1.4 something using your compass, or put your ruler, square root of 2. And pi over 6, 1. Distance 1. That distance is the same as this, 1. And then at pi over 2 direction, your r is 0 over here. Now, when your theta equals 2 pi over 3 is -1, which means opposite direction 1. So opposite direction will be just reflection here, right? Over here. And 3 pi over 4 here, also negative, opposite direction, square root of 2 over square root of 2. So, 3 pi over 4 opposite direction, which is a reflection of this. The length is same thing, so over here. And 5 pi over 6, opposite direction. Length minus square root of 3, it's the same direction, opposite direction. So this reflection point here, right? Something like this. So this, back to this. All right. So at pi, you're supposed to be here, but -2 will make it 2 to the other side, right? And then look at this. And then in that direction, 7 pi over 6, opposite direction, square root of 3. So same as this one. At 5 pi over 4, minus square root of 2, so the other side of square root of 2. It's the same thing as this, right? And over here, this is what? 4 pi over 3, right? Minus 1, opposite side 1, same as this, position lines. And 3 pi over 2, 0. And here, 5 pi over 3, positive 1. Same as over here, right? And then 7 pi over 4, square root of 3, same as over here, okay? 3 pi over 4 minus square root of 2, right? And over here, same thing. So it turns out that you go 0 to pi over 2, pi over 2 to pi, and pi to 3 pi over 2 one more time, 3 pi over 2 to 2 pi another. So you will go through this one twice. Looks like kind of circular, at least roughly. Now, another way to get this one more quickly will be this. Think about the graph of theta versus r. Now, this is not xy plane with polar coordinate. This is r theta imaginary, abstract plane where theta r behaves just like xy, rectangular coordinate system. You draw the graph of 2 cosine theta. Then you will get 2 pi over 2, 2, -2. So that means as theta goes from 0 to pi over 2, your r value drops from 2 to 0. So if you imagine the many different theta values, as theta increases, your distance from the origin decreases from 2, shorter and shorter and shorter, down to 1 and 0, right? As theta increases, the distance from the origin is getting smaller and smaller and smaller, down to 0, right? And if your theta increasing over here, right? Then 0 to -2, which means the other side 0 to 2, right? So not here, but to the other side. So from pi over 2 to pi, from 0 to -2 means the other side 0 to 2. So distance from the origin is getting larger and larger and larger, up to 2 over here. And then from pi to 3 pi over 2, as theta increases, your r value increases from -2 to 0. -2 to 0. Which means at pi, -2 at pi means 2 as your opposite side 2. As you go here, the other side 2 to 0. Right? -2 to 0 means the other side 2 to 0. Yeah, the other side 2 smaller than 0. Just like over here, going through this pattern exactly one more time. And then from here to here, yeah, 0, 2, again increasing up to 2. This pattern over here, right? So actually, this takes a lot of time and we don't know the in-between behaviors. This one gives us some rough idea of the continuous behavior of R as theta increases. So from now on, we will draw R theta as a rectangular coordinate in R theta plane, this abstract plane, to see how R changes as theta varies. And then in XY plane, we're going to make that R as a distance from the origin as theta increases like this. Okay? That's probably the most efficient way to sketch graph of R equals f of theta. So anyway, it looks like really a circle going through the origin. And actually in that case, we can prove it. How do we prove that? Well, you multiply both sides by R. R times R equals R times 2 cosine. Okay? I just multiply both sides of the equation by R. And you get R squared 2R cosine theta. And R squared in XY coordinate, X squared plus Y squared. Cosine theta, 2X. X squared minus 2X plus Y squared equals 0. By adding 1 to both sides, we can make completion of square. Okay, it's a circle with radius 1 centered at 1. Yeah, it looks like it because it goes through 2, 0 at origin, center 1, 0, slope radius is 1. Okay, as we can guess. All right, and so anyway, these graphs are all given in figure 878, appendix 58, page appendix 58. Okay? Now example 5. You already learned all of this in math analysis in high school or pre-calculus 2 in CSUB. It's more extensive than I first planned. As a review, sketch the graph of R equals 1 plus sine theta. This is same as example 7 on page appendix 59. So as I alluded here, from now on I'm going to draw this one in R theta abstract plane. Theta and R. Now sine theta will be going like this, right? 2 pi over 2, but between -1 and 1. Adding 1 will make it lifted by 1. So your center axis will be y equals 1. And you have to draw sine graph. Right? Right? This is at pi over 2, 2. So from 0 to pi over 2, from 1 to 2. Right? So we're going to draw that graph. Careful. As theta increases, okay, let's say this is 1 along the x-axis. At first, when theta equals 0, your length is 1, right? So I'm going to draw a bunch of these theta. Okay, now here, when theta equals 0, you start at 1. And as theta increases from 0 to pi over 2, r increases 1 to 2. So distance 1, but a bit longer and longer as we go up to, at pi over 2, 2. See? As theta increases, this is getting larger and larger. Something like this, right? It looks like getting longer and longer. You see? From distance 1 to 2. And then pi over 2 to pi, your distance r down from 2 to 1. So 1 will be minus 1, 0 over here, right? So length is now getting shorter and shorter and shorter. Something like this, right? So getting shorter and shorter and shorter and shorter, up to 1. Now pi to 3 pi over 2, even shorter, r equals 1 through 0. Getting even smaller and smaller and smaller and smaller and smaller and smaller, down to 0. So at the origin, you get at 3 pi over 2 back to the origin. From 3 pi over 2 to 2 pi, from 0 to 1. So getting longer and longer, right? So it'll be, upside down heart shape. We call it cardioid. Okay? Cardioid. Okay? You can take a look at figure 11, page Appendix 59. Now, just like we were able to find the symmetry of the graph of xy equation by doing instead of x to negative x is y reflection. Reflection through the y-axis. So if in your graph, if f of y equals f of negative x is in the end same as y equals f of x, which means f of negative x equals f of x, even function, then after y reflection, if you get the same equation, that means you have a y symmetry. Only when you have a symmetry with respect to y, after y reflection, you get the same graph, same equation, means same graph. If this is true, then y symmetry. Just like that. Or y to negative y make it, not this one, but let's say x equals g of y, or in general, in the xy equation, y to negative y change, it's actually give you the same original equation. Then after x reflection, you get the same graph, means you have an x symmetry, right? That's what you did in pre-calculus 1, right? Symmetry of the graph of xy equations. Just like that, we have the following symmetry checker. r equals f of negative theta is the same as r equals f of theta. Now, r theta to r negative theta. Theta to negative theta means reflection through the x-axis. This is reflection. The graph of this is reflection through the x-axis of this graph. Now, as an equation, this equation is equivalent to this. That means after x reflection, you get the same graph, which means you have x symmetry. You have an x symmetry. Symmetry with respect to the x-axis. All right? Likewise, or r equals f of theta plus pi is equivalent to r equals f of theta. What is theta plus pi? Theta plus pi over here. That's origin reflection. After origin reflection, you get the same graph, and you have origin symmetry. Okay? Thirdly, if r equals f of pi minus theta, r equals f of theta. Pi minus theta will be, see, if this side is theta, this will be pi minus theta. Same r. Okay? That's the reflection to the y-axis. So r equals f of pi minus theta is same as original equation. Then you have y symmetry. The graph of this will have the symmetry. Okay? Now, let's do the following example. Example 6. Sketch the curve y equals cosine of 2 theta. Okay, first of all, let's check some symmetries in this case. Let's say r cosine of 2 times minus theta. So this one, theta to negative theta conversion. Well, this is r equals cosine of negative 2 theta. But the negative of cosine of negative x is same as cosine of x, right? Original equation in the end. That's why you have theta to negative theta, x reflections, x symmetry. You have x symmetry first. What about cosine of 2 theta plus pi? Pi maybe on the other side. Origin reflection. 2 theta plus 2 pi. Well, cosine is 2 pi period. It's the same as cosine of 2 theta. Again, back to this. After origin reflection. So you have origin symmetry. Now, once you have 2 out of these 3 symmetries, then you get the other third one automatically. You can prove it easily. Or you can check, same thing. Cosine of 2 times pi minus theta. Cosine of 2 pi minus 2 theta. 2 pi period. So that will be cosine of minus 2 theta, which is again equal to cosine 2 theta. Again, you have y symmetry, as I expected. If you have these two, you will have third symmetry automatically. So, using this, if I draw the graph r versus theta, this one has period 2 pi over 2 pi, right? So pi pi over 4, pi over 2, 3 pi over 4, 5 pi over 4, 3 pi over 2, 7 pi over 4. And between 1 and -1. So it'll be so take a complete turn at pi and then repeat it again. Okay? Now, because of the symmetry, we can check only quarter 0 to pi over 2 behavior. Then from 0 to pi over 2, then reflect over the y-axis because you have a y symmetry, and then reflect over the x-axis because you have the x symmetry. So we need just a quarter of the entire graph to get the entire graph. So, as theta increases, so let's see what happens. From 0 to pi over 2, down to 1, starting from 1, at pi over 2, or pi over 4, starting from 1 and getting shorter and shorter down to 0. Something like this, right? Getting shorter and shorter. And then after that, from pi over 4 to pi over 2, 0 to -1. That means the other side, 0 to 1. Right? 0 or all the way to length 1. Longer and longer. Right? The graph will be like this. Length 1 here. Now, because of x symmetry, you can reflect over. Okay? Then you will have something like this. Reflect over. And then reflect over the y-axis. Or you can go through this pattern. You'll find that if you go through all the way we did in the previous example, if you trace, you'll find that this is first, second, and third, fourth, fifth, sixth, 7, and 8. We're going to come back to this. It's like a 4-leaf clover, right? 4 petals, rows of 4 petals, right? Okay, so you can check this. You know, when you have a even integer multiple, like sine 2 theta, twice number of petals, 4 petals. If you have cosine of 4 theta, or sine of 4 theta, or some constant multiple, you will have a 8 petals rows. Okay? On the other hand, if you have r equals 8 times cosine of 3 theta, or r equals 8 times sine of 3 theta, odd number, you have same 3 petals of rows, or 5 theta, 5 petals of rows, same thing. Now, we don't have time to go over all these things. You should have learned this within pre-calculus. Okay. Now let me check recording one more time. Alright. So far, all of these materials so far are done in pre-calculus 2. Now, this is a real calculus material. That is tangent line. So a curve represented by polar equation r equals f theta. Now recall, when you have y equals g of t, dy over dx was dy over dt over over dx over dt, or g prime of t, f prime of t. Remember? Section 3.4, we learned this. So, if you have a curve r equals f of theta, now we can make a geometry equation like this. Because x equals r cosine theta, y equals r sine theta. Now, r equals f of theta. Therefore, x equals f of theta cosine theta. So this is now geometry equation with parameter theta. Alright? Then dy over dx will be dy over d theta, d over dx over d theta. dx over d theta using product rule, f prime theta cosine theta plus f of theta. Derivative cosine is minus sine theta. Oh, that is dx d theta, sorry about that. dy over d theta, f prime theta sine theta, f of theta, sine derivative is cosine theta, over dx d theta, f prime theta cosine theta. So cosine theta is minus sine theta. That's how you get the derivative, dy over dx. So, example 7. For the cardioid, we got in example 5, find the slope of the tangent at theta equals pi over 3, pi over 2, and pi over 6. Okay, first of all, dy over dx is, this is your f theta. So f prime theta means cosine theta. Cosine theta plus times sine theta plus f theta, 1 plus sine theta times cosine theta, right? Our f of theta is this, f prime theta is cosine theta, over cosine theta minus 1 plus sine theta, sine theta. So what do you get? You have, let's see, cosine theta, sine theta, cosine theta, sine, cosine theta, factor out, you get sine theta, 1 plus sine, 1 plus 2 sine theta. Just factor out cosine theta. Here, cosine squared. Alright, this one, your denominator is cosine squared theta minus sine theta minus sine squared theta. Okay? Now, cosine squared theta is 1 minus sine squared theta. 1 minus sine squared theta minus sine theta minus 2 sine squared theta. So, this is minus 2 sine squared theta minus of 2 sine squared theta plus sine theta minus. I just take a minus sign. That will be 1, 2, 1, negative 1. So minus of sine theta plus 1, 2 sine theta minus 1. I'm going to take a minus in. And you get 1 minus sine 1 plus sine theta, 1 minus 2 sine theta. Minus getting in here, 1 minus 2 sine theta. So this is dy over dx in terms of theta. So, when theta equals pi over 3. Well, dy over dx, plugging in pi over 3, 1/2. 1 plus square root of 3 over 2 times 2, so square root of 3. Over 1 plus square root of 3 over 2, 1 minus 2 times the square root of 3. Multiply both sides by 2 to get rid of this, and 2 get rid of this. 2 square root of 3, 1 minus square root of 3, 1 plus square root of 3. Now distribute your denominator. 2 minus 2 square root of 3 plus square root of 3 minus 3. So you get 1 plus square root of 3 minus 1 minus square root of 3. Hey, negative of each other. So negative 1. Slope is negative 1. Okay? B, when theta equals pi over 2, dy over dx, pi over 2, cosine is 0. 0 times whatever is 0. Sine pi over 2 is 1, so 2 times 1 minus 2, whatever, 0. So that means horizontal. Horizontal, tangent line. C, theta equals pi over 6. Pi over 6, square root of 3 over 2, 1 plus square root of 1/2, so plus 1. So 2 to cancel, square root of 3 in the numerator. 1 plus 1/2. And 1 minus 1. So square root of 3 over 0. Undefined, going to infinity or negative infinity. Vertical, tangent line. Okay? Now note, remark. As theta approaches pi 3 pi over 2, positively or negatively, your dx, dy over dx equals actually 0 over 0 form, right? It's a 0 over 0 form, undefined. In that case, we have to use L'Hopital's theorem to find the slope. Okay? Alright, so when you have a 0 over 0 form, you need to do L'Hopital's theorem to determine whether it is horizontal, vertical, or something other than those. Alright? Okay, those are well discussed in detail. Page Appendix 61 for this case. Alright, that's the end of section Appendix H1. Okay? Alright, see you next time.